right, so today we are going to talk about graphs of categorical data. So first I have a little cartoon for you, right? We've got a pie chart. 80% of the pie chart looks like Pac-Man. The other 20% does not. So today we're going to create and interpret table and graphical representations of categorical data. So remember, categorical data is data that is categories. So when we ask a survey question to our survey people or sample, the answers they give are words or categories. So in this case, the survey question was, what type of food do you like to get for lunch? And the categories are burgers, tacos, nachos, bagel, and pizza. So just to kind of look at this bar graph we have here, I want to identify some of the pieces of this bar graph that make it a good representation of our data. So we have a graph title that shows the reader what this graph is about. We have the name of the categorical variable on the bottom x-axis, which is food types. We have along the x-axis the different categories of that categorical variable. So we have the 5 different food types. The height of each bar represents the frequency, so how many people in our sample said that thing. We have gaps between the bars, which show that these categories don't have anything to do with each other. There's not like a natural sequence to them necessarily. And then along the side, we have frequency, which basically just means how many, right? We said that before. So suppose Ms. Sorensen, one of our statistics teachers, took a survey of her first period class to determine people's favorite lunches and graphed the data in the bar graph on the previous slide that's on your notes. Bar graphs are the most common method of displaying categorical data, right? It's quick, it's easy to make, it's easy to read, it's a great graph. So some characteristics of bar graphs include that the graph title tells what's measured, as we saw on the previous slide, and the survey question is usually a good choice of a graph title. The responses are the categories at the bottom of the bars. So the responses to the survey question become the categories. If an individual can respond with more than one category, then their responses could be counted in each of the corresponding categories. So if it's a question where someone might say 2 of the options, they would be counted in both of those bars on the bar graph. Categories can be displayed in any order, it doesn't matter what order, and the gaps between categories just because or indicate that the categories don't have a natural sequence to them. So it doesn't matter what order they're in, and they don't really connect necessarily from one to the next. If the categories are displayed in descending order, meaning we start with the tallest bar and then go to the next tallest bar and the next tallest bar and the next tallest bar. If we organize our category bar chart like that, that is called a Pareto chart. Categories are allowed to overlap. So if we have a percentage graph or bar graph, the percentages could potentially be more than 100%. So categories overlapping means if it's a survey question where a person is allowed to answer more than one option, then we could end up with percentages that are more than 100 if we did a percentage graph. And lastly, not secondly, we could have bar graphs that are horizontal, in which case the axes would switch. So the categories would be displayed on the vertical axis, the y-axis, and then the frequency would be displayed horizontally on the x-axis. So it would basically just be flipped from what we saw on our bar graph. So it would just kind of be turned to its side. That is possible. So from that, or even we could start with this, we can create bar graphs from frequency tables and vice versa. So a frequency table is basically just a table where I have my categories on one column, and then on the other column I say the frequency, like how many or how frequently did each category get answered. So I'm going to use the bar graph to fill in the frequency table. That's pretty easy to do. If I look at the first category of burgers, I can see that we have 4 students who answered burgers, so I would put a 4 there, right? If I went back and looked at it, and hopefully you can look at your notes, for tacos, we had 4 people who answered tacos. There were 2 people who answered nachos. There was 1 person who answered bagel, and there was 2 people who answered pizza. So based on the responses, I gave that away, but based on the responses, how many students total did Mrs. Sorensen survey? It's tempting to think there are 13, right? Just adding up the numbers, that there were 13 students who answered the survey. But again, remember, this might be a question where they were allowed to answer more than one or more than one category. So if Ms. Sorensen allowed her students to give 2 different answers, what are your 2 favorite foods? Then they could be counting in more than one of these categories, which means there might be fewer than 13 people that answered this survey, right? So another graph that we can make for categorical data is a circle graph or a pie chart. It's a great way to compare the responses for categorical data. With a circle graph or a pie chart, the categories cannot overlap, which means we cannot have a survey where respondents can select more than one category. With a pie chart or circle graph, we have to have it add up to 100%. So when we look at our percentages that are in each category, they should add up to 100%. So we have to make sure the categories don't overlap, that respondents can only select one category. When you do circle graphs, you can actually use actual numbers, but typically we see circle graphs used with what we call relative frequencies, which is basically a percentage or a proportion. So we usually think of circle graphs as being like 100% is the whole circle, and we split it up based on what percent is in each category. You can label each that's supposed to say slice. I just wasn't paying attention when I typed this. Or use colors and a legend. So you can label the slices, or you can color them different colors and make sure to use a legend or a key that tells what color each category is in. So for example, I have this responses. This was Tanya asked her classmates how many pets they own, and the responses are in the title below. We're going to sketch a quick circle graph. If you were doing the on the computer version of this notes, it might be hard. You can use the line tool to draw lines and then kind of sort of color them in. It might be a little tricky for you to draw the circle graph on the computer, but do your best, or maybe just write it on your own sheet of paper. Okay, so the first thing I'm going to do is I'm going to figure out what the percentages or the relative frequencies are. So in order to do that, I have to know how many total students I have. Remember, in a pie chart, nobody can answer more than one category, which makes sense here. The number of pets you have can't be in more than one category, right? It's got to be in one of these categories. So I'm going to figure out how many total people we have. So let's see, 6 plus 12 is 18, plus 4 is 22, plus 2 is 24. Right? So we have 24 people total. So for this category of none, we could do in our calculator 6 divided by 24, and then multiply that by 100 to get the percentage, which would give me 25%. So 25% of the respondents, of the classmates, have no pets. For 12, again, we're going to do 12 divided by 24, and then multiply by 100 to get the percentage. Is 50%, because 12 is 50% of 24. And so that's the people who have 1 to 2 pets. For the people who have 3 pets, 4 divided by 24, and then multiply by 100 gives me 16.7%. And then lastly, we have 2 divided by 24 times 100 is 8.3%. So when I go to transfer that to my graph, I'm going to title it number of pets. I'm going to first split my graph in half because I do have somebody or one of these categories is 50%, so I know that will be exactly half. And I'm going to split it into a quarter, right? Half of half is a quarter because we have our 25% section, which can go into that little part right there. And then I'm just kind of estimating where that 8.3% and 16.7% might be, right? So 16 is double 8, so I can kind of try to make it to where that slice is about twice the size of that slice. It doesn't have to be perfect. We're just trying to get as close as we can to a good representation. If you really wanted to, you could pull out a protractor and really make this amazing. Okay, so I'm going to label my sections. My 50% section was 1 to 2 pets. No pets was 25%, so I'm going to put that there. 3 pets was that 16.7%, which was this one right here. And then 4 or more pets was this little guy right there. So again, I can label each slice individually with words. If I wanted to be real fancy, I could color each of those slices a different color, and then put a little key or legend off to the side that said what each color represented in terms of the categories. We could also make relative frequency bar graphs, which means we could use a bar graph and put percentages along the side. So now that we know the percentages, we could go ahead and put this as a bar graph. Now I did that for our original data way back over here when we were looking at this table. So I went ahead and put those numbers as percentages the same way I just talked through that for our last question. So I figured out kind of how many responses total there are. Again, not necessarily how many people, but how many responses. And then I did some division. So 4 divided by 13 times 100, 4 divided by 13 times 100, etc. So I did all of that and created this bar graph. So I can kind of see that burgers, about 30% of the responses were burgers, about 30% of the responses were tacos. Looks like about 16-ish% of the responses were nachos, like 8-ish%, 7 or 8% of the responses were bagel, and maybe about 15% were pizza. Right? So when I compare this graph to our original bar graph for that data and look at how they look, you'll notice they look pretty similar, right? The only real difference in terms of how they look is the y-axis. Our vertical scale is now percentages instead of, on the original graph, it was numbers or frequency. So how many versus what percent. So a couple of things to note when we are making conclusions by looking at bar graphs and pie charts. You're expected to describe what you see from these graphs and compare the frequencies or relative frequencies for different categories. So talk about like which category had the most people answer that or the most responses, which category had the least, were there any that were very similar in terms of their frequencies. So talking about what you see and comparing it. And then lastly, we talked about kind of avoid making graphs misleading. So a lot of word processing programs and like Google Sheets and Microsoft Excel will have these options for 3D pie charts. They look cool, but they often distort or kind of misrepresent the slices and make them appear bigger or smaller than they really are. Pictures should be proportional to the frequencies they represent. We'll kind of look at what that means. I have a couple of examples, but we have to be careful about using pictures in place of bars on a bar graph because it can sometimes distort things. And then lastly, we want to be careful about not having your y-axis start at 0 because that can make differences look much larger or smaller than they really are. So you can use that says 0. It's supposed to say like a little squiggly line. I'll kind of show what I mean in a minute. So a couple of graphs. This one right here is a very fancy schmancy pie chart that looks like a burger to represent how many times a week someone or you choose fast food as a dining option for your family. So again, it looks very cute. It's very cool looking, but that 33.8% section looks like a lot more than 33.8%, which should be a third. That looks like more than that, and so we just have to be really careful. And then just in general, it's like that smaller section, it looks a little bit bigger. So a section like this, we want to make sure that we are being careful with 3D graphs. For this one, they used a kind of picture to replace the bars, but because the picture is changing in its width as well as its height, that first carton is about half the size of the second one in terms of the y-axis, but it looks like more like a fourth of the size because we're changing the width and the height. So it's just misleading, so we have to be careful about that. And then this last one, it makes the differences between the two groups look really big, especially for the orange one, which is the post-test score. So it's making it look like the difference between traditional instruction and using software is like huge, when really it's not that big. It's a little bit more than 10% in terms of score. But because they didn't start the axis at 0, the y-axis at 0, it made that difference look a lot bigger. So the axis is broken, meaning it doesn't start at 0. They didn't use like a little squiggly line to represent that the axis doesn't start at 0. Usually that little squiggly line kind of tells us that it doesn't start at 0. So we know to look for that. So that is just a little bit about one variable graph.